Hi everybody, I wanted to make a quick video that may help explain how the RVUs, the resource value units, essentially work on the node servers being built. As I understand it, RVUs are going to be generated based on these 5 factors. The first one is CPU time in hours. The second, memory usage in gigabytes. The third, bandwidth used in gigabytes. Fourth, storage used in gigabytes. And fifth is uptime, essentially making sure the server is on and functioning at 99.99% of the time. All of these factors are going to be calculated into a formula of coefficients that weigh the importance of each one of those 5 factors, each one of those metrics, and that will give the owners, this coefficient will give the owner of the node, us, essentially, an RVU payment, a resource value unit. I don't have a node to show you how this will function on a real node server, but I'm showing you on my own personal computer these metrics essentially functioning in real time. The processing functions of the node server will be similar, but again, this is for illustrative purposes. This is no claim for how the node will actually function. I'm just showing you the guts of a computer and its performance. So, as Sean was saying, as we put a load or a burden on these nodes, that's how those RV units kind of start factoring in, those times start getting calculated. So on my computer right now, you'll see a video I'm going to render in 4K. Again, it's not necessarily going to function how the node does, but you'll see with my task manager open, you can see the performance of my computer functioning now. So you can see my CPUs running just at a base of 22%. Memory is 11.8 gigabytes. My hard drives are at 0%. The Ethernet, that really won't be factored in, but that is not reading anything. And then the GPUs, I have 2 graphical processing units to render the videos. And so basically everything's at 0 or fairly low. But when I start to delegate a load or put a burden on this computer, I'm going to export this and you will see. There we go. As you'll see, everything starts to get ramped up. And so the CPU right then and there, we're putting a burden on that processing power. So the RVU is CPU time in hours. And so the clock is starting and I'm running my CPU at this higher rate. It was just sitting at 9%, now it's at 41%. You can see the memory went from 11.8 gigabytes to now 16.6 gigabytes. This is all happening in real time, and then both of the graphic cards are running almost at peak, or 2/3. They bounce between the two, so you can see what is happening on the servers itself if this was a node server. Again, the Nexus Node Network customers or anybody will be doing something similar. They're going to be asking their server to be executing some kind of computation. For me, it's rendering a 4K video in this example. And you can see all of the resources being used at this time for that processing power. And so essentially, this time is all getting calculated on the fly. And then at the end of the month, I'm assuming this gets billed out to the client at whatever the coefficient is, the calculation, the formula. And that's how the fee, I guess, is calculated. But again, this is not to describe any of how it actually is working. It's just to show you how this computer is actually functioning when a task is being delegated to it. And again, I can still see it being built. I can still see the video rendering itself out, and will be saving on the hard drive. Once it is saved, you'll see that the hard disks will be utilized as well. Again, guys, I'm hoping this is just a good visual of how the servers function, and then again how RV units or RVUs are generated on those 5 factors: CPU time in hours, memory used in gigabytes, bandwidth used in gigabytes, storage used in gigabytes, and of course the uptime. It's got to be working for it to generate some revenue. But yeah, you can see it's now writing to the hard drive itself, and you can see that this is writing to the drive itself, wherever it's being stored. Then yeah, right down here it says it is done. So yeah, that's the video.